Yes, good afternoon, all. This is Simran, and we are dealing with the operational research subject. And on the first unit, we have in the previous class we have been learned about the big M methodology, the way of solving problems in the case of linear programming technique that is utilized for the easy way of getting the optimum way of solution in the operational research methodology. Before this is an example, we have been already solved the one example in the previous class. Let's have a look at it once, and what are the sequence of steps that need to be followed as per the previous class in the for solving of this big M methodology. Step one requires that identification of the constraints, that is RH said there should be a non-negativity of a value, and if at all the RHS said there is any non-negativity of a value, have to multiply with respect to -1. That is the first step need to be identified, and hence we will be getting that the sign conversations are converting in the step 2, that each inequality constraint to a standard form that will be of greater than or equal to the 0, and definitely it is not beyond the value of 0. And in the third step we will be adding an artificial variable to the constraints which has been identified in the step 1, that is after equating the 0, and considering m as an large positive number. If the linear programming is a minimum problem, adding of this artificial variable to the large positive number for getting an objective function, and hence if all the variables are equal to the 0 in the optimal solution, will be found in that optimal solution to a original problem. If any artificial variables are positive in the optimal solution, then we'll be considering the original problem that is infeasible, because even we are having two different constraints or conditions here. The non-negativity will not be accepted, and next one, a large way of solving the problem will be concised with respect to the multiplication of a large positive number denoted by m. If at all the artificial variables are in the negative constraints, and we will be adding this the large positive number with respect to the sign conversion, that is negative m into ai. So these are the steps that we have been learned in the previous class for solving this problem in the case of big M method. M is nothing but a very large positive number, and we have been solved this orange juice problem also in the yesterday's class. And moving on to the today's class, another one more example and the way of solving with respect to an graphical representation and obtaining the equations by utilizing the normal way of linear programming technique, that is nothing but the polynomial equation generation. And after getting that equation, solving that equation as per the conditions just we have been learned, that is in the case of this linear programming strategy, application of these five different steps need to obtain the feasible solution. And after getting the feasible solution, we'll be obtaining some variables and considering that constraints, and getting an answers related to the existing variables. Those values we will be taking and plotting a graph as per the values obtained by solving the constraints, and we'll be identifying yet where the peak level is being existing in the case of problem identification or solvation of the problem, and how to overcome the difficulty existing in the problem. So let us move on with respect to the problem, that is Parlac Limited has two products, heaven and hell. So hence Parlac is a manufacturing company that is having manufacturing is being manufacturing two different products. First one is an the name of two different products are, one is heaven and second one it is hell. To produce one unit of heaven, again heaven is subclassified into the different composition. Upon upon getting the heaven, there is an composition, there is 2 units of material X and 4 units of material Y are required. So hence there are two different constraints we have been obtained here, that is X and the next one is Y. And that is also with an upgradation of units, that is 2 units of X and 4 units of Y material. And we will move into the second category, that is second category of the Parlac, that is hell. To produce 1 unit of hell, 3 units of material X and 2 units of material Y are required. So same constraints has been categorized here, but the nomenclature of heaven and hell has been deviated or differentiated with respect to the composition of the X and Y materials, because here the problem clearly specifies that heaven consists of 2 units of material X, that is nothing but 2x plus 4 units of material Y, that is 4y. 2x plus 4y is equal to heaven, let it be H. 2x plus 4y is equal to H. Next one, simultaneously for the hell, that is He, 3x plus 2y. So that is equal to He, that will be He. So these are the two equations having two constraints, and there is an equating variable. Only 16 units of material X and 16 units of material Y are available. Material X cost. So hence the composition of material or stock of the material X and material Y in the case of units has been specified here. Material X cost of rupees 2.50 per unit, and hence per unit material X costs of 2.50, and simultaneously material Y costs of 0.25 per unit respectively. Okay. Required formulate an linear programming model in the shortcut LP, linear programming model, and solve it graphically. So graphically we need to show the difficulty of manufacturing with the composition that is required for the heaven and as well as the hell, and depending upon that the cost variations and how much cost for each and every unit of heaven and each and every unit of hell are required need to be identified. For example, 2x plus 4y, and hence x is given with a cost of 2.50 rupees, and y has been given with an 0.25 rupees per unit. And hence, for in the case of two heaven, 2 units of x materials, 4 units of y, that is 2 into 2.50 plus 4 into 0.25 is equal to heaven. So we'll be seeing the possible equations that are required. So calculations for as per the linear programming formulation that we are having in the case of big game method, optimization or generation of these polynomial equations as per the constraints given and with respect to the coefficients that has been given. And material A 2.50 into 2, B material 0.25 into 4. So for heaven there is 5, and hence 2.50 into 3 different units and 0.25 into 2 different units. And for the hell that is cost of 8 rupees and heaven cost of 6 rupees. Considering X represents the number of units of heaven, okay, Y almost given to the hell. We are considering for our convenience. To be produced, the objective is to minimize the objective function. So minimization. Let us move on with the minimization. Nothing but cost effective need to be reduced upon the bulk manufacturing as per the question given to us. There is nothing but overall composition has to be utilized for manufacturing of both this hell and the heaven, and considering that minimization is equal to z. So that is an upon both integration minimization z is equal to heaven having of 6 and x plus 8y. So here 6 represents the heaven, and next 8 represents the hell cost. So upon minimization that is equal to 6x plus 8y, and leads to the constraints as in the polynomial equations format. 2x1 plus 3y less than or equal to 16. That is an maximum terminology existing of x constraint, and simultaneously 4x1 plus 2y less than or equal to 16 maximum material of y constraint and have been considered. But we are all aware of the second big M methodology point, that is it should be non-negative. So almost all the categorizations are non-negative. Hence x comma y is greater than or equal to 0. That is definite, because negative signatures or negative values are doesn't existing as part of our considerations or constraints given in the question. And moving on with respect to the next one, one second. Hence, the introduction of step 1, finding the vertex of each constraint by treating the constraint of inequality nature as equality. So, considering the first equation, that is when the x constraint has been taken in the form 2x1 plus 3y is equal to 16, substituting of when x is equal to 0, we will be obtaining the y terminology, that is 16 by 3. Simultaneously, when y is equal to 0, we will be getting the x terminology, that is 16 by 2, that is equal to 8. Thus, taking the two different vertices, that is x1 y1 and x2 y2, and simultaneously substituting the similar case of values when x is equal to 0 and y is equal to 0 in the case of equation 2, that is 4x1 plus 2y is equal to 16 with the same constraint values. Based upon that, we are getting y value is equal to 8 and x value is equal to 4, and hence the another vertices are we are getting, that is 0 comma 8 and 4 comma 0. So x value is 4 and y is considered as 0. Simultaneously x is 0 and 8, and hence we are having here 0 and 3, and almost it will be of 3 5 is 15, 15.1 something, and 8.0 it clearly specifies. So let us see what are the steps need to be considered in the case of plotting the graphical representation. Moving on to the second one, we are having this x and the y terminologies as x1 y1, x2 y2, x3 y3 in the case of second equation solvation, and x4 y4 of in the case of fourth way of solvation. But how these values can be analyzed that these are feasible for plotting the graph? That is the main constraint here. So plotting both the coordinates of the first constraint on the graph and joining them by straight line and shading the feasible region, which will be having a convex to origin in case of less than type of inequality. So inequality, we all know that it is unequal, the values obtained or equating values, and we'll be seeing that same values that are being plotted as per the tabular column specifies. We have been taken that 0 0 for 0 comma 16 by 3, 2 comma 4, 4 comma 0, simultaneously 0 comma 8. So taking the value and values, plotting here, it is here the equational values 4 comma 0, simultaneously 0 comma 16 by 3, simultaneously 0 comma 8, and hence 2 comma 4 and 8 comma 0. Also here 8 comma 0, when we have been in the second point adjusting the equation to equation 1 and 0 comma 16 by 3 and 8 comma 0, and joining this point with respect to this point first equation line and moving to the second equation line, that is 0 comma 8 and 4 comma 0, and joining this line the intersection of the line considering as a point E, that is generation at a, where at which point is being getting. So at x value 2 and y value 4 nominally, we are getting an intersection point of both the equation 1 as well as the equation 2. Right? So let's have a look here. This is an equation 1, this is an equation 2. And the values, that is 0 comma 16 by 3 and 8 comma 0, 0 comma 8 and 4 comma 0 plotted, and getting the values of intersectional point of these two equations at this one 2 comma 4 point. And the feasible answer is nothing but there is no any profit, no any gain, but the marginal profit earned will be existing upon composition of manufacturing both heaven and hell will be existing under this dome line holding under or under this equilibrium point range, and hence here the alphabetical order is given, that capital A, capital E, capital O, and F. So here the polygon of A, E, O, and F. These four different sides we are having, just like as in trapezium. So hence, if the composition varies within this particular dome level, then there is no any that is nothing but equal existence of the composition will be attaining upon solution, and hence z number 1 gives the minimum value of z, that is x, with x is equal to 0 and y is equal to 0 at the phase levels of substituting in the equations obtained as per the diagram. So considering the second condition, that is maximization. So in the case of minimization of 0 by application of x is equal to 0, y is equal to 0, we have obtained, and the corresponding graph has been identified here. And let us consider in the case of maximization of the same kind, what will be getting to be happen. So with different values, we have been considered here different values. So here the question is maximize the function f of x comma y 80x plus 70y subject to the constraints. So taking the similar values, and correspondingly we are having the following set of equations given in the questions format, that is 2x plus y less than or equal to 32. The conditions and constraints: x plus y less than or equal to 18, x plus 3y less than or equal to 36, and hence x comma y is definitely greater than 0. So we need to realize that we are having two different constraints, and variables are two different variables, and RHS side variables. So we are having only the one set of axes, that is x comma y, are definitely non-negative values or non-negative variables as per our big M method of knowledge. Hence x comma y is greater than 0. So that is clearly specifies in the given problem. And we all aware of that getting the values of to any one side, that is left hand side, corresponding to a system of equations when only one constraint has been considered, that is y. Let this 2x is being 1 and the corresponding equations are generated, that is y is equal to minus 2x plus 32, y is equal to minus x plus 18, and y is equal to minus 1 by 3 of x plus 12. So the LCM has been taken, and upon solvation 1 minus 1 by 3 of x plus 12. So the polygon which represents the feasible region in the case of these identifications. So first one it is 0 comma 0, and applying the similar 0 comma 0 considerations here. When x is equal to 0 has been applied here, y is equal to, which is definitely minus 0 plus 32, that is equal to 32. And hence if the 0 has been substituted here, y is equal to 18. And here 0 substituted, that is equal to 12. So 32 is an one constraint, 32, 18 and 12. So 2x. Getting the similar case of values here x and y, that is 20 comma 16 as per the equating strategy of values, and 50 beyond, and considering t and 50 percentage and t and maximum of 100 percentage, and simultaneously on the y axis being on with respect to the 150 to 100 category. So taking the values, following table constrain the values containing the vertices, there is 0 comma 0, 16 comma 0, identifying the values as per the given polygon level, right? So 16 comma 0, 14 comma 4, 19 comma 9, and 0 comma 4. And corresponding values has been given. At the 0 origin, it is definitely 0, and 16 comma 0, 480, they have been finalized, and 14 comma 4, 4, that is an unit of manufacturing, that is 1400, and yet and 9 comma 9, 1300, and 0 comma 12, 800. So the maximum value that is considered is 1400. So maximum, the maximization problem, as per the given variables, we need to pick up the 1400 as a value in the maximization and occurs at 14 comma 4. So upon the feasible constraints on the diagram, that we are taking the maximum value. So minimization that we have been seeing here at 0 comma 0 definitely specifies the minimum minimization of value. And in the case of this, at the point 14 comma 4, getting the 1400 as a maximum value, and at the x and y variables of 14 comma 4. And similarly, taking the problem with respect to the functionality, that is maximization of the function f of x comma y 143 x plus 60y subject to n constraints. So the equations given here, x plus y less than or equal to 100, 120 x plus 210 y less than or equal to 15,000, 110 x plus 30 y less than or equal to 4,000. And definitely, as per the methodology or the solving of linear programming technology, that we are having that x comma y are non-negative numbers, and hence it has been given correctly that x y comma y is greater than or equal to 0. Considering the corresponding system of linear equations upon equating x plus y is equal to 100, and second equation 120 x plus 210 y is equal to 15,000, 110 x plus 30 y is equal to 4,000, x comma y is equal to 0. So only considering the equating strategy. So before we have been considered that minimization, and in the second case we have been considered as a maximization, and in the third way, for maximization strategy, we are doing the maximum constraint with respect to an equating strategy. So verifying here as per the given diagram, checking on the vertices to find the maximum of solutions, where what point they're having a more strategy of values. So there are two different points at point number one and the point number two as per the equation one. This has been joined here. As per the second equation, which is point, and here we are having a point and join the other two. And third, we are having a point one here and point two here and join this as per the third equation. And upon integration of these two, there are two different points of equation 1. Let it be the equation 1, let it be the equation 2, and let it be the equation 3. And upon these three, we are having three different intersectional points. Simultaneously, it may be obtained at 20 and next at 60. It is clearly specified here, this is the mutual point. And hence, second, for equation 2 and 3, we are having here is the point. That is for constituents, we maybe of x is equal to 15 and y is equal to the maybe of 80 or something else, 15 gamma 80. And here the intersection of domain, that is x leads to maximum of 70 and y leads of below 50 level, and feasible constraints regarding these three different axes, these three different aspects. So considering this is the point which is having the highest y value, and considering this intersectional point having the highest x value, but lowest in the case of y value. And upon both the strategies, in the case of maximization level with respect to x constraint, this point will be acceptable. In the first case, as we have been solved the problem. Moving on to the next strategy at this particular range, there's as the y constraint moving with respect to this particular point, there will be a maximum lead constraint here. And upon equating the both strategies need to be identified, that is very much feasible in the given graphical representation, and the value which is being identified, that is 20 comma 60, is existing in between the x and y coordinates of maximum y, that is 100, and a maximum x, that is 100. So 110. In between these two limitations, the equation 20 comma 60 are being existing. And hence, in the case of this third emerging strategy, that is equating, not in the case of minimizing, not in the case of maximizing, with both the constraints x and y, the moderately or the medium based solution leads to the vertices to find the maximum value, that is 64, 68 points 20 comma 60. So this is the third step of the three way methodologies of solving the linear programming case of problems by utilizing the Bingham method and satisfying the steps as per the methodology. Thank you.